We have talked about ranges for numbers and how weird things happen if you use a number that's out of the range for the data type. So we're going to look at that a little bit more in detail. Now over here we have some typical ranges for C++ data types. A lot of what we use over here is an integer, minus 2 billion to plus 2 billion. An unsigned integer goes from 0 to 4 billion. A signed integer is the same thing as a regular integer. Also a short integer only takes 2 bytes, and we'll actually use that for the example. So notice that it goes from negative 32,768 to positive 32,767. There's also an unsigned short, which goes up to about 65,000. We have over here a long integer. You see that it goes from 9 billion minus to positive 9 billion. Over here we have a signed long integer. Okay, so a short integer only takes 2 bytes. So the largest short in binary is all ones over here. Now, if you add 1 to it, then 1 plus 1 is 0, carry 1. The carry 1 is added to this one over here. 1 plus 1 is 0, carry 1. The carry 1 is added to this one over here. And it just cascades over here. So you end up with all zeros over here in the space for the 2 bytes for that short integer, and a 1 over here. And that's overflow, and it's just lost. I always say it's lost in the big bit bucket in the sky. So there's actually a nice link over here on tutorial point about the ranges of data types. You see that over here. Let me show the address too. And you see over here the primitive types, over here the ranges, some programs you probably recognize, the size of, function, and you know, some other stuff. Okay, but we're going to be using the short integer over here as an example. So what we're going to do is we're going to declare a short, and we call it test variable, and this is the upper end of the range. It's all ones over here, and we're going to just show it over here, then go to the next line, and now we're going to add 1 to it. And when you add 1 to it, you get where do we have that again? Yeah, over here. We'll just use this comment. Okay, so all zeros over here means that you're not going to get any of the values for the bits over here, and it goes back to that largest negative number. And then we're going to deduct 1 again to make it underflow. And then you'll see that we get back to the original value. So over here we start at the top end of the range. Then by adding 1, weirdly enough, we go all the way to the beginning. And then when we subtract 1, then we go back over here to the very end again. And you can see that over here we start at over here this number, then we go 1 up, which takes us all the way back over here. Then we try to deduct 1 again, which takes us to the outside of the negative range over here, and that makes it automatically go back to the top end of the range. So it kind of wraps around both ways. So that's what happens when you have overflow and underflow.